Good morning everyone, welcome back to Diksha Karnataka YouTube channel. Wake up now, it is time for your final exam today of physics obviously. So you guys are nervous, don't be nervous, it will be okay. So time to revise all the important questions, 20 most important questions in less than 30 minutes. That will include 15 2 marker and 3 marker questions and 5 derivations, very important derivations. So don't miss this video just before your exam. So I don't want to waste too much time in talking because today is the final day. So let us see the important questions. State and explain Coulomb's law in electrostatics. This is the first question. Obviously it can come as a 2 marker question. State and explain Coulomb's law in electrostatics, 2 marker question, or they might ask you state and explain Coulomb's law in vector form. So in vector form, if they ask you the same question, how to modify the same answer for vector form, you have to show 2 charges, q1, q2, and you have to show that this is vector r cap, this is force F vector, this is force F minus vector, okay, and then you have to write the same thing, F equals to 1 by 4 pi epsilon naught q1 q2 by r square r cap. So this is the vector form. In vector form, diagram compulsory, vector notation compulsory, okay. If you mention this is force, then you have to mention the other side is minus F, so it is accepted. Now obviously the statement, I don't want to repeat it too many times, so let's see the statement. Coulomb's law states that the electrostatic force between 2 point charges is directly proportional to the product of the magnitude of 2 charges and inversely proportional to the square of the distance between them. It acts along the line joining the charges. Mathematically, F is equal to 1 by. This is normal Coulomb's law. If it is vector form, from here onwards it will be this one, okay. So now let's move on to the next question. Write any 3 properties of electric charge. Very important. So additivity of charges are additive in nature. All the charges are integral multiple of smallest charge E, that is called quantization of charge. Conservation of charges, total charge in an isolated system is conserved, okay. So in an isolated system, very important, isolated system must be mentioned, that total charge in an isolated system is conserved or constant. Next question, write 3 properties of electric field lines. Another very important question, electric field lines. Now here we are only discussing electric field lines. If the same question comes for magnetic field lines, you can answer first 2 points, okay, except the last point. Last point will be just opposite. If the same question comes from magnetic field lines, obviously you have to change electric field to magnetic field, that is obvious, but what else you have to do? You have to mention that magnetic field lines do form closed loops, okay. So that is the only change. Other than that, this is the same statement. If you remember this question, you can answer 2 questions. One is electric field lines, another one is magnetic field lines, okay. Obviously electric, in case of magnetic field lines, you have to mention electric field lines start from north pole and end at south pole, and inside the magnet it goes from south pole to north pole. That is the major changes. Other than that, 2 electric field lines never intersect. Magnetic field lines also do not intersect, okay. Another point you can mention that tangent drawn at any point gives the direction of electric field. Same point can be used for magnetic field lines as well. So one stone, 2 birds. So this is one question that is done. Now next is what factors does a capacitance of a parallel plate capacitor depends. So first of all, you have to write the equation for parallel plate capacitor. Here will be K here, and you have to mention that directly proportional to the area A, inversely proportional to the distance between the plates D, and directly proportional to the dielectric constant K kept between the medium. So that is very clear, I hope. Now next, write two properties of equipotential surface. It is also very important question. No work is done in moving a test charge over an equipotential surface. Electric field is always normal to the equipotential surface at every point. Okay, no two equipotential surfaces can intersect each other. This is also very super important question. Now mention two limitations of Ohm's law. Another important question. Ohm's law is applicable only if all the physical conditions remain same. Ohm's law is not applicable at very low and at very high temperature. Ohm's law is not applicable to non-ohmic devices like semiconductors, discharge tube. Okay, these are the devices where you cannot apply Ohm's law. Let's move on. State and explain Biot-Savart's law, write its vector form. So first of all, this diagram is compulsory in the statement of Biot-Savart's law. Okay, there is a point, there is an arrow. This arrow represents the vector dl. Okay, this is called current element. Current needs to be shown in the circuit, that is I current is flowing, and the distance r must be shown. This angle theta must be shown. Okay, and this is called current element, obviously, as I mentioned. So this diagram must be drawn, and then you have to write it. It is directly proportional to the strength of the current, directly proportional to the length of the current, directly proportional to the sign of the angle between the current element and the line joining and midpoint of the current element, and inversely proportional to the square of the distance between them. The mathematical expression, if they ask you mathematical expression, then you have to remember dB equals to I dl sine theta by r square. Obviously mu naught by 4 pi should be here. Okay, so this is the mathematical expression for Biot-Savart's law. Okay, super important, must be remembered. Right, now next, what is Lorentz force? Write the expression and explain the terms. So force acting on a moving charge particle in the presence of an electric and magnetic field is called Lorentz force. So F is equal to Q into E plus Q into V cross B. Okay, Q is charge, E is electric field, V is velocity of the particle, and B is magnetic field. Okay, very simple, very easy, but you have to remember it. Next question is, how can a galvanometer be converted into a voltmeter? Explain with the diagram. A voltmeter should have been very high resistance as it's connected in parallel in the circuit. This line is very important. Next, a galvanometer is converted into a voltmeter by connecting a suitable high resistance in series with it. This way overall resistance of the voltmeter remains very high. This is the circuit diagram. Okay, this is current Ig. So Ig into R plus Rg equals to the voltage that you are measuring. So R plus Rg equals to V by I or Ig, obviously. So R equals to V by Ig minus R. This is the mathematical formula for the unknown resistance. Okay, if you write it, very good, optional, but if you write it, it is very good. Okay, there will be no chance of the teacher to deduct any marks. Next, how can a galvanometer be converted into an ammeter? Explain with diagram. So an ammeter should have a very low resistance as it is connected in series in the circuit. This is achieved by connecting a suitable low resistance S in parallel called shunt with the galvanometer. This way overall resistance of the ammeter remains low and the galvanometer is converted into an ammeter. This is the circuit diagram. Obviously, as you know, we have connected in parallel a shunt, and again Ig into Rg equals to I minus Ig into Rs. Okay, from here you can calculate Rs, very simple, Rg Ig by I minus Ig, as simple as that. This is the formula. Optional, again optional, but good to write. Next is write three differences between diamagnetic, paramagnetic and ferromagnetic material. So any one of the difference will come Okay, there is a 99% probability that one of the difference will come. So first of all, you remember what are all the points. Magnetic behavior means diamagnetic, weakly attracted, weakly repelled by the magnetic field. Paramagnet, weakly attracted by magnetic field. Ferromagnet, strongly attracted by the magnetic field. Okay, magnetic susceptibility, small and negative. Magnetic susceptibility, small but positive. Magnetic susceptibility, large and positive. Okay, so this is the magnetic susceptibility. Effect in magnetic field. Okay, it induces a magnetic field in the opposite direction of the magnetic field, induces a weak magnetic field in the direction of magnetic field, induces a strong magnetic field in the direction of magnetic field. Okay, magnetic moment, sorry. So these are the very important points to remember before your exam. Now next is obviously derive the expression for motional EMF induced in a straight conductor. So motional EMF, very expected question. So obviously first thing you have to remember that there is a magnetic field into the page of the paper. The wire is moving in this direction. The diagram is very important. Okay, this cross obviously represents the magnetic field B, and what is the flux linked with this? Flux is basically, you have to start with the expression for flux. Flux is magnetic field into area. Now what is area in this case? Area is length into breadth. So length is L, and breadth is x. So this is the this is the flask linked with the coil. Now what is the rate of change of flask? Rate of change of flask. Why we are trying to find rate of change of flask? Because from Faraday's law, the induced EMF is given by rate of change of flask, right? So from there we can write d dt of BLX. Now B and L are constant, so they will come out of the differentiation. Only thing that will be left is dx dt. Now dx by dt is nothing but the speed v, okay, with which it is moving, so it is BLV. So induced EMF is BLV. Okay, you have to write in the bracket v is equal to dx by dt. Very simple, easy derivation, and with the diagram you can score full 3 marks. Now write 3 features, properties of nuclear force. The nuclear force is much stronger than the Coulomb force. It is one of the strongest, it is the strongest force, okay, acting between charges and the gravitational force between the masses. Nuclear force between two nucleons falls rapidly to 0 as their distance is more than a few femtometers. Nuclear force between neutron, proton, and proton is approximately the same, but that means that nuclear force is independent of the charge. Okay, so it is very important to remember that nuclear force is independent of the charge. Next, give Einstein's explanation of photoelectric effect and write Einstein's photoelectric equation. So Einstein suggested that Einstein's photoelectric equation is obviously h nu equals to phi plus half mv square. Okay, here h nu is the frequency, h is Planck's constant. This is called work function of the metal surface. This is mass of electron, and v is the velocity of the ejected electron, okay. So these are the things, this thing you have to remember. Einstein suggested that each photon of light has energy proportional to its frequency nu, given by E is equal to h nu, where h is Planck's constant. When light shines on a metal surface, photons transfer their energy to electrons in the metal. Any energy from the photon exceeding the work function becomes the kinetic energy of the ejected electron. What are intrinsic and extrinsic semiconductor? So intrinsic semiconductors are pure semiconductors that are called intrinsic semiconductors. The presence of charge carriers, electrons and holes in an intrinsic semiconductor are property of the material, and these are obtained as result of thermal excitation. Okay, whereas in extrinsic semiconductor, number of charge carriers can be changed by doping or suitable impurity in the pure semiconductors. Okay, such semiconductors are known as extrinsic semiconductor. So you dope a pure semiconductor, then it becomes an extrinsic semiconductor. Okay, examples are n-type and p-type. Okay, now let's move on. Derive an expression. Now we have 5 derivations. I will give you I will remind you the important formulas as well, so don't go anywhere. Let's check the derivations one by one. Derive the expression for electric field at a point due to an infinitely long, thin, uniformly charged straight wire using Gauss's law. So long straight wire using Gauss's law, we are trying to find electric field at a point R. So first stage is to construct a Gaussian surface of radius R and length say L. Okay, length is L, radius is obviously R, and the charge per unit length is given by lambda. So total charge enclosed by this Gaussian surface G is given by lambda L, right? Charge per unit length is lambda, total charge should be this into this, right? Now what is Gauss's law? From Gauss's law, E dot ds, actually phi equals to E dot ds, and that should be equals to Q enclosed by epsilon naught, right? Q enclosed by epsilon naught is the formula for Gauss's law. We all know that. Now in this case of cylindrical Gaussian surface, due to symmetry, the E must be constant, so it will come out of the integration. Okay, only ds will be left with. And what is Q enclosed? Q enclosed we already written, that is lambda L equals to epsilon naught. You have to mention that due to symmetry. Okay, if you write it, very good. Now next is, what is the ds? ds is surface area. Now surface area of this curved surface, I told you multiple times, surface area of the curved surface is given by 2 pi r L, that is equals to pi lambda L by epsilon naught. L cancels, so E equals 1 by 2 pi epsilon naught lambda by R. Okay, this is the electric field, expression for electric field. If you do that with slight in between explanation, you will get full marks. The diagram is compulsory, the initial writing and the final writing is compulsory. Okay, you have to write it, you don't just need to do this mathematics. This is just mathematical parts. Writing, you have to write it in between to explain whatever you are doing, like you do in mathematics. Same thing you have to do here as well to get the full marks. Now next is arrive at the balanced condition of Wheatstone bridge using Kirchhoff's rules. So balanced condition of Wheatstone bridge, obviously Wheatstone bridge is like Kaju-Katli. Those who knows what is Kaju-Katli is. So this is the. Now what you have to remember, that in case of balanced condition, there is no current passing through the galvanometer. So no current passing through the galvanometer means at balanced condition, no current pass through galvanometer. So this current, this is P, this is Q, this is R, this is S. Okay, so whatever current is passing through P, the same current will pass through R as well. Okay, I have done in a different way in different classes, but this is the easier one to remember. Okay, if you have studied that one, that is also fine, but this is the easier one. Okay, now we will apply first A, B, C, D. So first we will apply A, B, D, A. First loop is applying KVL, that is Kirchhoff's voltage law, in A, B, D, A. A, B, D, A. Why we write it like that? We start from A and we end at A. That is why it is called a loop. Okay, that is how you write a loop. So first is this one. So P into I1, P into I1. Now there is no current passing through this, so we can completely ignore the G part. We will come here D, and then D to A. While going to D to A, we see that we are going against the current. So against the current means minus Q into I2. and no battery is connected in this loop, so it will be equals to 0, or Pi1 equals to Qi2, or P by Q equals to I2 by I1. This is equation number 1. Next, again we will apply the same KVL in the loop DCBD. DCBD. Okay, this is the second loop, DCBD. Now again we are going in the direction of current, so S into I2 minus, now we are going opposite to the current, I1 into R, and that here is no current, so this should be equals to 0. Okay, now again we have to solve it. IR1 equals to I1R into SI2, or R by S equals to I2 by I1. So this is equation 2. Comparing 1 and 2, we get P by Q equals to R by S. This is the condition for balance. Now there was 1 or 2 times it came as only draw the Wheatstone bridge and mention the condition for balance. So draw the Wheatstone bridge, this is the condition for balance. So that might come as a 2-marker question. So you might remember the diagram and the condition obviously. Okay, so this is a 2-marker question, only this much is 2-marker question, and including this much is 5-marker question. Very easy derivation. Okay, highly probably will come in your year for your final exam. Now derive the expression for magnetic field at a point on the axis of a circular current loop. So we have a circular current loop and we are trying to find the magnetic field. This is the most difficult of them, of the all derivations that we are doing, but this is highly probably will come, so that is why we are doing it. So now you have to remember that the radius is R, this distance is x, so from Pythagoras theorem this will be square root of R square plus x square. What else? This angle you have to remember is phi. The magnetic field at this will be dB, and because of this we will only take the x component, that is dbx. Y components will be cancelled. Okay, y components, due to symmetry, you have to mention, due to symmetry y components will cancel, only component left will be x component. Now what is dB? From Biot-Savart's law, we have already seen Biot-Savart's law tells us mu naught by 4 pi I dl by r square. Now there is a sine theta, but in this case this component dl and this distance vector, they are perpendicular, so theta is equals to 90 degrees, so sine 90 is 1, so we will not include that in our calculation. So dbx, what is x component? If this is phi, it can be shown that this angle is also phi. So if this is phi, this is also phi, that means this is the adjacent component. So dbx is nothing but db cos theta, db cos phi, right? So just do that. These are the steps that you must remember. Now what is dB? dB is mu naught by 4 pi and I dl. What is r square? R is this basically, right? This is the distance between the elements, so r is this, so r square will be r square plus x square. Okay, square root whole square, so that will gone. Now cos phi, what is cos phi? Cos phi is, if this angle is phi, cos phi is adjacent side divided by hypotenuse. So adjacent side is r and hypotenuse is square root of r square plus x square. Okay, so this is the basic structure. Now we have to organize it little bit. Mu naught by 4 pi I r by r square plus x square to the power 3 by 2. So this is 1, this is half, it will be 3 by 2 into dl. Okay, now we have separated dl. Now total magnetic field x bx will be equals to, everything will be same, mu naught by 4 pi, okay, IR by r square plus x square to the power 3 by 2 integration of dl. Now integration of dl, close integration of dl means what? You are starting here, you are taking small dls and adding them, that is the total perimeter of the circle. So perimeter of the circle is 2 pi, perimeter of the circle is 2 pi capital R. Now 2 pi, 4 pi is, one of them is cancelled, so you get mu naught by 2 I r square divided by r square plus x square to the power 3 by 2. Right, now this is the very important derivation. Now next two derivations are very easy. So first of all, full wave rectifier, half wave rectifier. Okay, and these are the very important derivations. This is the circuit diagram for full wave rectifier, which is mostly expected. Maybe half wave rectifier will come in your exam. Just revise the circuit diagram. Rectifier is an electronic device that converts alternating current into direct current. Positive half cycle of AC input during the positive half cycle of the AC input voltage, the upper half of the transformer secondary winding. So during the first half this diode conducts, during the second half this diode conducts, but in both cases the current passed through the RL in the same direction. That is why it is called a DC conversion. And this is the input voltage, this is the output voltage, and this is why it is called, it was two directional previously, now it is unidirectional, that is it is converted into DC. So negative half cycle, positive half cycle, both half cycle you have to explain, you have to draw the circuit diagram and the output waveform as well. Now similarly, what is half wave rectifier? In half wave rectifier there is only one diode, only one load resistance. So this diode functions only during the positive half cycle, that is the first half cycle. It does not work in the negative half cycle because there is no other diode connected here to help it. Now there is a slight difference between the circuit diagram. Here if you see that diodes are connected like this, but the common point is taken from the center, which is very important. Okay, common point is taken from the center and load resistance is connected like this. Whereas in the half wave rectifier it is connected, only one diode is connected, no common point is there, it is simply only one circuit, very easy. Okay, now again in the half wave rectifier, first half only diode conducts, second half no conduction happens. So this is the input waveform, output waveform looks like this. Okay, so I hope that you have understood it. Now let us remember few important formulas. So first of all, my favorite chapter is alternating current. So first, what is XL? XL is omega L or 2 pi into F into L. F is frequency. What is XC? Steps you have to remember. First you have to calculate the inductive reactance, then capacitive reactance. Capacitive reactance is 1 by omega L or 1 by 2 pi F into L, F into C. Now you have to remember that capacitance is generally given in microfarad. So that microfarad 10 to the power minus 6 plus 6, whatever it is, that has to go up because that is negative in the denominator. It will go up in the positive, it will become positive, and that will give you a value for this XC. So be careful about calculating XC. Now what is the impedance? Impedance is formula is simple, it is R square plus XL minus XC whole square. Okay, what is the phase difference? Phase difference is tan inverse XL minus XC modulus by R. Modulus means whoever is bigger minus smaller. Okay, this is the phase difference. Now power factor cos phi is Z R by Z. Power factor cos phi is R by Z. Okay, this itself is power factor, no need to find phi. Cos phi itself is power factor. One more thing, resonance frequency is given by 1 by 2 pi square root of LC. Be careful with calculating resonance frequency. Again, because of the factor that C is a 10 to the power of negative term. If L is also 10 to the power of negative term, be careful. Only even numbers of power can be taken out of the square root by halving them. If it is coming 10 to the power of minus 7, 10 to the power of minus 8, then you have to either add just one extra zero inside. Be careful while calculating the resonance frequency. Right, now what else? Next is obviously concepts from ray optics. I am suggesting these two chapters right now. So ray optics mirror equation is 1 by V plus 1 by U equals to 1 by F. Now sign convention is very important. Anything on the left hand side is negative, anything on the right hand side is positive. That means x-axis along positive x-axis is positive. U is always negative. Okay, for concave maybe lens, maybe mirror, it is focal length is always negative. Okay, and for convex, okay, focal length is always positive. be it lens, be it mirror, does not matter. This is the mirror equation. Lens equation is 1 by v minus 1 by u equals to 1 by f. Okay, what else? Lens maker formula 1 by f equals to n minus 1 1 by r1 minus 1 by r2. But for any problem, if it is coming as a numerical, you need to remember plus and minus will be cancelled and you will get 2 by r. Okay, this is for numerical problems only. Okay, what else you have? Total internal reflection sine critical angle theta c is equal to 1 by n. This is important. Now is this is total internal reflection. Next is prism. Prism is basically mu equals to, or n equals to sine a plus delta m by 2 divided by sine a by 2. I hope your revision is completed. If you are watching this for the first time, don't forget to subscribe to our channel, and I wish you all the best. Everything will be okay, and at the end of your exam I will be coming back with a live paper analysis session. Don't miss that out. Okay, I will discussing all the MCQs answers, all the fill in the blanks answers, all numerical answers, along with the difficulty level of the questions. If you have any other doubts, you can ask me in the live session as well. So I will see you in that there, but till then, all the best. Concentrate in your studies, and I know that your exam will be perfect and many of you will score out of out. Till then, bye.